For over half a century, brave explorers have ventured beyond our home planet. We have learned to live and work in the cruel vacuum of space, but the time has come to go beyond the horizon, for humanity to once more venture into deep space. Our return will not be easy, but armed with the latest innovations, we will, once again, set foot on worlds beyond our own. Only this time, we won't just be visiting, we'll be building something that lasts, a sustainable future beyond the Earth. In today's Mars mission update, we'll be taking a detailed look at the fully reusable spacecraft poised to send astronauts to the Moon and Mars, SpaceX's Starship. We'll cover the development of the first Starship prototypes, the key milestones along the way, and what to expect next from Starship flights later this year. We'll also recap the latest updates on NASA's Artemis program, and finally, we'll go over the 3 robotic missions that recently arrived at the Red Planet. SpaceX's Starship will be the world's first fully reusable orbital class rocket. Designed to realise the vision of building a sustainable civilization on Mars, Starship's ability to transport large numbers of people and cargo is set to revolutionise how we access space. The Starship system is comprised of 2 parts, a 9-metre wide upper stage spacecraft called Starship and a lower stage booster called Super Heavy. Towering above its surroundings, the 120-metre tall Starship system will be the most powerful rocket in history. A Starship orbital launch begins with the ignition of the Raptor engines at the base of the Super Heavy booster. Super Heavy lifts the Starship until stage separation, after which the booster reorients itself and reignites its engines to return to the launch site. Large grid fins allow Super Heavy to precisely descend beside the launch tower, where the booster is caught in mid-air. Re-landing, refueling, and reusing boosters in this way allows more frequent missions at substantially lower launch costs. Meanwhile, in orbit, the cargo-carrying Starship opens its payload fairing to deploy satellites into their target orbits. With its mission complete, Starship returns to Earth using the heat shield on its underside to survive the temperatures of atmospheric re-entry. Starship then plunges through the atmosphere, belly first to lower its terminal velocity, using aerodynamic fins to steer the vehicle and control its descent. Finally, just hundreds of meters above the ground, Starship reignites its engines, flips to a vertical orientation, and comes in to land. But the Starship system can do much more than just launching large payloads into Earth orbit. One of the unique features enabled by the reusability of this system is the ability to rapidly launch multiple Starships carrying additional fuel. These tanker Starships dock with the main vehicle in orbit, transfer propellant, then return to Earth. Refueling with multiple tankers in low Earth orbit allows Starship to reset the rocket equation and hence transport around 100 tons or dozens to 100 people into deep space. The fuel itself, liquid methane and liquid oxygen, confers another advantage, since liquid oxygen can be made from water ice on the Moon and Mars, while liquid methane can be made from carbon dioxide from the Martian atmosphere. This unique combination of rapid reusability, orbital refueling, and local propellant production is the cornerstone for sustainable human settlements beyond Earth. In the 5 years since the Starship system was first announced, SpaceX has made tremendous progress in the design, construction, and testing of Starship prototypes. The Starship hardware program began in earnest in late 2018 with the construction of a scaled-down demonstration vehicle called Starhopper at SpaceX's Boca Chica site in South Texas. Starhopper underwent a series of short test flights, or HOPs, culminating in a 150-meter test flight in August 2019. These tests were the first in-flight demonstration of the Raptor engine used by the Starship system. Starhopper was followed by two full-scale Starship prototypes called Mark I and Mark II, assembled over the course of 2019. But while undergoing initial pressure testing, the Mark I vehicle ruptured in November 2019. Meanwhile, the Mark II vehicle undergoing construction in Florida was deemed unflightworthy and discontinued. But the Starship program rapidly accelerated in 2020 with the expansion of SpaceX's Boca Chica site, now known as Starbase, into a sprawling industrial complex. At Boca Chica, starships are built via an assembly line whereby ring segments, tanks, and other components are progressively assembled before vertical stacking and integration of the vehicle. This efficient process allows multiple starships to be built simultaneously, allowing quick vehicle testing and iterative refinement of the design when issues are encountered. In the first few months of 2020, the key focus was on cryogenic pressure testing, the same test that failed the Mark I prototype. In January 2020, SpaceX subjected 3 small test tanks to cryogenic tests, filling them with liquid nitrogen to pressures of up to 8.5 bar. The lessons learned from these test tanks were fed into subsequent full-scale Starship prototypes. Following Mark I and Mark II, the Mark III Starship was renamed SN1 for serial number 1 and subjected to a cryogenic pressure test in February 2020. But while pressurized with liquid nitrogen, SN1 was destroyed due to bad stainless steel welds. Just weeks later, in March 2020, SpaceX demonstrated a solution to this issue by building and testing a small tank called SN2 that successfully passed cryogenic testing. The next full-scale Starship prototype was SN3, which underwent cryogenic testing in April 2020. Alas, an accidental pressure release in the lower fuel tank caused SN3 to crumple and succumb to the weight of the upper tank. Each of these distinct failure modes ultimately improved the design of the tanks, enabling the next prototype, SN4, to become the first full-scale Starship prototype to survive cryogenic pressure testing in April 2020. The cryogenic testing campaign in early 2020 illustrates a key guiding principle of the Starship program. Rapid prototype construction allows quick innovation to fix issues with the design as they are discovered. Following cryogenic testing, the next stage in pre-flight operations for a Starship prototype is a series of static fires. This involves one or more Raptor engines briefly firing while the Starship is held in place. SN4 was the first full-scale Starship prototype to undergo static fire tests, successfully completing 4 static fires in May 2020. But shortly after the 5th static fire test, a ground support equipment issue led to a liquid methane leak, causing the vehicle to experience an unplanned ignition event. After 4 weeks of repairs at the launch site, operations resumed in late June 2020 with the testing campaign for the next prototype. SN5 successfully completed a cryogenic test and a static fire by the end of July 2020, setting the stage for the Starship flight test campaign. On August 4th, 2020, SN5 fired a single Raptor engine and became the first Starship prototype to fly since Starhopper. SN5 reached a maximum height of 150 meters, translated under controlled flight, deployed landing legs, and successfully touched down on the landing pad. 1 month later, on September 3rd, 2020, the next vehicle, SN6, conducted its own 150-meter test flight, following a similar profile to SN5 and also successfully landing. Parallel to the SN5 and SN6 campaigns, 2 small test tanks, called SN7 and SN7.1, were constructed and underwent cryogenic tests to study the limits of alternative steel alloys for use on future starships. Ultimately, the successful low-altitude flights of SN5 and SN6 provided a proof of concept for a new generation of Starship prototypes that would launch to much higher altitudes. In late 2020, SpaceX began the high-altitude flight test campaign for Starship. The main goals of high-altitude Starship tests, as illustrated in this animation, are threefold. First, to reach altitudes of over 10 kilometers using 3 Raptor engines. Second, to transition into a so-called belly flop free-fall maneuver while maintaining aerodynamic stability and control. And finally, to reignite the engines, flip to a vertical orientation, and gently touch down on the landing pad. The first Starship prototype to undergo high-altitude testing was SN8. This was the first vehicle to be fitted with aerodynamic control surfaces and flaps, 3 Raptor engines intended for flight, and a nose cone. After arriving at the launch site in late September 2020, SN8 underwent 6 weeks of ground tests, including cryogenic testing and multiple static fires. At long last, on December 9th, 2020, SN8 took to the skies over South Texas. Around 4.5 minutes into the flight, SN8 reached its peak altitude of 12.5 kilometers, hovered in midair, then cut thrust and pitched over into the belly flop position. SN8 demonstrated a controlled freefall for over a minute, using its flaps for stability. Finally, about 6.5 minutes into the flight, 2 Raptor engines reignited, the vehicle flipped vertical and came into land. But at the last moment, a loss of pressure in the methane header tank led to an insufficient fuel supply, reducing the thrust and causing an explosive impact on contact with the landing pad. But despite SN8's fiery demise, this extraordinary flight successfully achieved all test objectives, apart from the landing on the very first high-altitude flight test. SN8 was followed by 3 similar Starship prototypes that launched in quick succession in early 2021. Just 7 weeks after the flight of SN8, Starship SN9 launched to a 10-kilometer altitude on February 2nd, 2021. All appeared well until the landing burn, when only 1 Raptor engine reignited. Without sufficient thrust to become vertical, SN9 met its end on contact with the landing pad. Less than a month later, Starship SN10 launched on March 3rd, 2021. Just like SN8 and SN9 before it, the ascent and descent phases of SN10's flight proceeded well, but unlike its predecessors, SN10 reignited all 3 Raptor engines before intentionally dropping down to a single engine to achieve the first intact landing for a high-altitude Starship prototype. Alas, the landing speed was still a little too high at 10 meters per second, which damaged the base of the vehicle and caused it to experience an unintended combustion event 8 minutes after the landing. SN10 was followed 4 weeks later by the 10-kilometer test flight of SN11 on March 30th, 2021. The launch day for SN11 was beset by a thick fog over Boca Chica that obscured much of the flight. Nearly 6 minutes after launch, a methane leak in one of the Raptor engines caused a fire, leading to a mid-air explosion at an altitude of about 650 meters. Shortly afterwards, pieces of SN11 rained out of the sky onto the landing site. At first glance, the loss of 4 high-altitude prototypes may seem like a significant setback, but what sets the Starship program apart from traditional rocket development is that the program is iterative by its very nature. Every time something goes wrong, it provides valuable lessons that can rapidly be implemented in the next prototype. Ultimately, Starship will be a much safer and more reliable vehicle if all the failure modes are discovered and corrected at this stage before it flies regularly. While SN8 through SN11 were conducting flight tests, SpaceX was hard at work preparing for the next phase in the program. Shortly after SN8's flight, a new test tank called SN7.2 underwent cryogenic pressure testing in late January and early February of 2021. SN7.2 differs from previous test tanks and full Starship prototypes in that it uses 3mm thick steel instead of a 4mm thickness. This reduced thickness could be a key upgrade for future Starship prototypes, resulting in up to a 25% weight reduction. Around the same time, SpaceX also decided to discontinue Starship's SN12, 13 and 14, which would have been similar to previous prototypes, opting instead to focus on the first of a new generation generation of vehicles, Starship SN-15. Compared to previous prototypes, SN-15 has many new upgrades. These include major structural improvements, a lower overall mass, updated flight software, and newer Raptor engines. The engine upgrades are particularly important since many of the landing issues for SN-8 through SN-11 were associated with the engines. SN-15 launched on its 10-kilometer flight test on May 5, 2021. Like previous launches, it successfully ascended to its target altitude, transitioned into the belly flop maneuver, and flipped vertical. Under the power of 2 Raptor engines, SN-15 gently touched down on the landing pad, becoming the first Starship prototype to successfully survive a high-altitude flight test. A small fire near the base of the vehicle following the landing was soon extinguished. After several weeks of inspections, SN-15 was rolled back to the production site on May 26th and mounted on a display stand. So what will the Starship program have in store for us next? The successful flight of SN-15 concluded the high-altitude flight test program, so SpaceX has paused all work on other high-altitude Starships that were under development. This includes SN-16, which is currently on standby in the high bay, and the prototypes SN-17, SN-18, and SN-19, which have all been discontinued, because now the ultimate goal for this year's flight tests will be an orbital flight test to altitudes exceeding 100 kilometers. But to achieve this next milestone, Starships alone will not be sufficient. To reach orbit, SpaceX will need to build super heavy boosters. SpaceX has been manufacturing super heavy booster segments since at least September 2020. The first booster prototype, called BN-1, began assembly in November 2020 and was fully stacked to a height of 70 meters in March 2021. BN-1 was only intended as a manufacturing pathfinder for subsequent vehicles, and so it has since been decommissioned. SpaceX is now building the first super heavy booster intended for flight tests, combining parts from BN-2 and BN-3, which is in an advanced stage of construction and will eventually host 29 Raptor engines. But before testing this booster, SpaceX has built a miniature super heavy test tank called BN-2.1, which completed its first cryogenic proof test on June 8th. Parallel to developing the super heavy booster, SpaceX is now working on the first orbital Starship, SN-20. Orbital Starships will host 3 sea-level Raptor engines and 3 vacuum-optimized Raptor engines. The vacuum Raptor engine is under active development, with the first full-duration test firing having occurred in September 2020. Orbital Starships will also have an array of hexagonal tiles on the belly of the vehicle to survive the extreme temperatures of re-entry. SpaceX has already tested small quantities of these tiles on high-altitude Starship flights, with each Starship prototype having more heat shield tiles than those before. Another important piece of preparatory work for the first orbital Starships came from a nose cone stress test in late April. This saw a nose cone subjected to similar forces to those a Starship would experience at the condition of maximum dynamic pressure, or max Q, the point of greatest stress during an orbital launch. The first orbital Starship flight is currently planned to see SN-20 launch from Boca, Chica later this year. 170 seconds into the flight, the booster will separate from the Starship and make a partial propulsive return, coming down in the Gulf of Mexico 8 minutes after launch. Meanwhile, the Starship will attain a near-orbital velocity, travel 3/4 of the distance around the planet, and re-enter Earth's atmosphere. Should it survive re-entry, the Starship will attempt a soft ocean landing 90 minutes after launch, splashing down around 100 kilometers from the Hawaiian island of Kauai. The main objective of this first orbital flight will be to gather empirical data on how the Starship vehicle and its heat shield performs during re-entry, allowing future prototypes to be further refined for spaceflight. To prepare for the orbital flight, SpaceX is now building the ground infrastructure to support the flight. As of June 2021, an orbital launch pad is being constructed alongside a launch support tower that will eventually stand 143 meters tall. In the near future, SpaceX is planning to expand the Boca Chica launch site with a second suborbital launch pad, a second landing pad, 2 Starship or Super Heavy test stands, and 2 orbital launch pads. The precise launch date of the orbital flight is not yet set in stone, but SpaceX has been pursuing an aggressive timeline for many months that at one point was targeting this July. However, given the need to finish ground support infrastructure, to thoroughly test Super Heavy boosters, to further refine the Starship heat shield, and to assemble and test over 20 Raptor engines, I have tentatively estimated on our future timeline that an orbital launch will occur around October of this year, though a delay of a few more months is certainly plausible. This is consistent with the timeframe listed in a recent request SpaceX submitted to the Federal Communications Commission for the orbital test flight. If you have any thoughts on this timeline, which I stress is speculative, or perhaps you're watching in the future and want to tell me how wrong I was, please do comment down below. Once orbital flights commence, achieving SpaceX's long-term vision of multiple Starship flights per day will require another key innovation: sea launch platforms. Sea launch platforms can more easily accommodate a 30-kilometer exclusion zone around a Super Heavy launch, required due to the acoustic energy of up to 32 Raptor engines, allowing for more frequent launches. Sea platforms may also catch returning Super Heavy boosters directly, allowing rapid turnaround for the next flight. In August 2020, SpaceX purchased 2 retired oil rigs, renamed Phobos and Deimos after the moons of Mars, which are currently being refurbished to service the first sea launch platforms. If all goes well, either Phobos or Deimos could be testing operations by the end of this year. A promising application of frequent Starship launches from sea platforms will be Earth-to-Earth flights, whereby a Starship launches from one platform, travels on a suborbital trajectory, then lands on another platform. In theory, these flights could allow passenger travel between any 2 points on Earth in less than 60 minutes. The sea launch platforms currently under development could hence lead to hypersonic travel around the world, with the first test flights beginning in as soon as 1 to 2 years. But of course, Starship was designed from the outset with the goal of carrying people beyond Earth. So to understand how Starship will fundamentally change our ambitions in space, let's take a look at the current state and near future of human spaceflight. For the last 2 decades, the nexus of human spaceflight has been the International Space Station, or ISS. Assembled between 1998 and 2011, the ISS emerged from a collaboration between the United States, Russia, Europe, Japan, and Canada. The ISS is principally a scientific research platform, orbiting the Earth at an altitude of about 400 kilometers. Human crews have continually operated the ISS since 2000. With visits from over 240 people from 19 nations. Although many early missions to the ISS used NASA's space shuttle, Russia's Soyuz became the only way for astronauts to reach the ISS for the better part of a decade after the space shuttle fleet retired in 2011. But the way we access space is now undergoing a profound transformation. On May 30th, 2020, a SpaceX Falcon 9 rocket launched NASA astronauts Doug Hurley and Bob Behnken to the space station. The Crew Dragon capsule carrying them became the first privately operated spacecraft to transport astronauts into Earth orbit. This mission, called Demo 2, marked a turning point for NASA. Instead of operating their own vehicles under the Commercial Crew program, they can instead buy flights to Earth orbit, currently with SpaceX and eventually with Boeing's Starliner. Since Demo 2 returned to Earth in August 2020, there have been 2 further Crew Dragon launches. On November 16th, 2020, the Crew 1 mission launched the first space station crew rotation from the United States since the retirement of the Space Shuttle. On board were NASA astronauts Shannon Walker, Victor Glover, and Mike Hopkins, alongside Japanese astronaut Soichi Noguchi. Their 6-month mission concluded with a successful nighttime splashdown on May 2nd, 2021, and just 1 week beforehand, on April 23rd, the Crew 2 mission also launched to the ISS, carrying French astronaut Thomas Pesquet, NASA astronauts Megan MacArthur and Shane Kimbrough, and Japanese astronaut Akihiko Hoshide. The Crew 2 mission is also a milestone in reusable space travel, since this mission used the same Dragon capsule as the Demo 2 flight, and the same Falcon 9 booster as the Crew 1 mission. But what makes Crew Dragon unique is that now it is approved for general human spaceflight, it can also be used for a wide variety of missions. The first such mission will be Inspiration 4, where a crew of 4 private citizens will spend 2 to 4 days in low Earth orbit aboard the same Crew Dragon as the Crew 1 mission to raise awareness for St. Jude Children's Research Hospital. Scheduled to launch in September, Inspiration 4 will mark the first spaceflight fully crewed by non-professional astronauts, though SpaceX is providing basic mission training for the crew. The success of Crew Dragon demonstrates a new model for human spaceflight based on public-private partnerships. By creating fixed-price contracts for a service, such as ferrying astronauts to the space station, NASA can select which companies to work with to build a goal-oriented space program. One of the significant benefits of this approach is the freeing of resources and funding for NASA to focus on deep space exploration, beginning with the return of astronauts to the moon. The Artemis program is NASA's flagship initiative to return humanity to the lunar surface this decade, potentially as soon as 2024. The key difference between Artemis and the earlier Apollo program is that Artemis is designed to follow a sustainable approach, culminating in the establishment of an outpost at the moon's south pole. The Artemis program will commence with the Artemis 1 mission. This will see the first launch of NASA's new heavy lift rocket, the Space Launch System, or SLS. The SLS will launch an uncrewed Orion capsule to the moon. During this 1-month mission, Orion will fly multiple times around the moon, coming as close as 100 kilometers above the surface before returning to the Earth. Preparations for Artemis 1 have made significant progress in the last few months. On March 18th, the first SLS core stage successfully completed an 8-minute hot fire test, simulating the flight profile for a launch. Following this test, the Artemis 1 SLS core stage arrived at the Kennedy Space Center. 6 weeks later, on June 11th, the first SLS core stage was flipped vertical in the Vehicle Assembly Building. The following day, the core stage was slotted between the 2 solid rocket side boosters. If all goes well, the Artemis 1 SLS and Orion capsule could be fully assembled in August, ready for a fueling test on pad 39B in September. The official target launch date for Artemis 1 is currently no earlier than November this year, but given the remaining work to prepare the SLS and Orion for this flight, a more realistic estimate would be around March of 2022. The second mission in the Artemis program will be Artemis 2, the first mission with crew. Artemis 2 will see 4 astronauts embark on a 10-day free return trajectory around the moon to test Orion's hardware and software. Currently estimated for a September 2023 launch, Artemis 2 will become the first human spaceflight beyond Earth orbit since 1972. And since one of the 4 astronauts will be a Canadian, Artemis 2 will also represent the first time that a non-US citizen will travel into deep space. The next major milestone will come with Artemis 3, which will be the first human landing on the moon in the 21st century. A key component of Artemis 3 3 is the Human Landing System, for which NASA recently selected a specialized variant of SpaceX's Starship. Artemis 3 will begin with an uncrewed lunar Starship launching into Earth orbit. Shortly afterwards, one or more tanker Starships will launch into orbit, rendezvous with the lunar Starship, and transfer propellant. The lunar Starship will then set out towards the Moon, where it will wait for up to 100 days in lunar orbit. Meanwhile, 4 astronauts will launch on the SLS towards the Moon. Once they arrive, the Orion capsule will dock with the lunar Starship, and 2 astronauts will transfer over. The lunar Starship will then undock and deorbit using an array of soft landing thrusters to gently land on the Moon. The 2 astronauts will then descend via an elevator on the exterior, becoming the first people to walk on the lunar surface in over 50 years. The astronauts will spend nearly a week conducting experiments before launching from the surface, transferring back to Orion, and returning to Earth. The selection of Starship for NASA's Human Landing System has major implications for the Artemis program and the future of human spaceflight. During the Apollo program, a maximum of 5 tons could be landed on the Moon, so many concepts for later Artemis missions have assumed only around 10 tons could be landed on the surface, but Lunar Starship profoundly alters this picture. If fully fueled in low Earth orbit, Starship can deliver over 50 tons of cargo to the Moon and still return to Earth for reuse. If instead Starships are used for one-way cargo missions, potentially as much as 200 tons can be delivered to the lunar surface. This dramatically higher cargo capacity and payload volume could significantly increase the scope and ambition of future Artemis missions. The path of Starship development fits naturally within the timeline of the Artemis program. Following the first orbital Starship flight, an important milestone will be the demonstration of propellant transfer in orbit. In October 2020, NASA selected SpaceX for a $50 million contract to demonstrate the transfer of 10 tons of cryogenic liquid oxygen between tanks on a Starship vehicle before the end of 2022. This will establish the underlying technology required for missions to both the Moon and Mars with Starship. In April 2021, NASA announced that Lunar Starship is their chosen human landing system for the first Artemis landing. This $2.9 billion contract provides SpaceX with NASA funding for 2 Lunar Starship missions. First, they will demonstrate the concept by landing an uncrewed Lunar Starship on the Moon. Assuming this demonstration is successful, Lunar Starship will then be used to land astronauts on the Moon for the Artemis 3 mission. Alongside these Lunar Starship missions, a private mission called Dear Moon is also planning to carry 10 to 12 people around the Moon as early as 2023. But note that the dates on this timeline are tentative and will likely change, especially since NASA is currently reviewing the Artemis program's schedule. But perhaps what is most striking about the selection of Lunar Starship is that SpaceX's proposal was far cheaper than the alternative submissions. For comparison, the second most highly ranked proposal from the national team, led by Blue Origin, requested $6 billion to produce a lander capable of delivering 14 tons to the lunar surface. So the next alternative would have cost NASA more than double SpaceX's award for about 30% of the payload mass of a fully reusable Starship. SpaceX also offered to fund more than half the development costs for Starship themselves, representing a significant cost saving for NASA. Consequently, SpaceX was the only company awarded a human landing system contract for Artemis 3, though other companies will be able to bid for subsequent moon landings. By securing a highly capable lunar lander at a fraction of previously estimated costs, NASA can now envision a more ambitious lunar exploration program. The ability to affordably land hundreds of tons on the lunar surface could finally enable the establishment of a large international outpost on the Moon. The foundations for this vision are already being laid, with 9 countries having recently signed the Artemis Accords to agree common principles and commitments for activities on the Moon. So in the not too distant future, humanity will be living and working on another world. The official partnership between NASA and SpaceX to develop the Starship system for crewed spaceflight will also provide a solid foundation for the first human missions to Mars. SpaceX currently envisions sending 2 uncrewed cargo starships to Mars in the 2024 launch window. These starships will enter the Martian atmosphere, much like a starship returning to Earth, using their heat shield to survive entry, their fins to control the descent, and finally a propulsive landing. The goals for this first Mars mission with Starship are to confirm local deposits of water ice, identify hazards, and place basic infrastructure such as power, mining, and life support systems. If all goes well, the first human mission could launch as soon as the 2027 Mars launch window. This mission will involve 2 crew starships and 2 cargo starships landing within a few kilometers of each other, likely in Arcadia Planitia. This mission will bring a propellant plant online to refuel starships, producing their methane and oxygen fuel from both water ice deposits and carbon dioxide from the Martian atmosphere. Ultimately, this first crewed mission will lay the foundational infrastructure for Mars Base Alpha, which will become the first human settlement on a planet beyond Earth. While SpaceX's Starship provides the transportation service, NASA's decades of experience in human spaceflight and robotic Mars missions will be key to the success of this endeavour. Though many challenges remain to be solved, such as life support systems for Mars and the large-scale use of Martian resources, a partnership between SpaceX and NASA is well placed to overcome these obstacles. NASA's endorsement of Starship for lunar landings provides a clear pathway for SpaceX and NASA to work together in sending the first people to Mars within this decade. But to realise this lofty vision, it's more important than ever to deepen our understanding of the Martian environment. So with the fleet of robotic explorers at the Red Planet growing ever larger, let's examine what we stand to learn from the 3 new missions that arrived at Mars this year. The year 2020 was a record-breaking Mars launch occasion. Once every 26 months, space agencies around the world looking to efficiently travel between the Earth and Mars can launch onto what is known as a Hoffman transfer orbit. July 2020 was one such launch window. During this month, 3 countries launched to Mars: the United Arab Emirates with their HOPE mission, China with their Tianwen-1 mission, and the United States with the Perseverance mission. These 3 missions took around 7 months to reach the Red Planet, arriving in February 2021. The first mission to arrive at Mars this year was the UAE Space Agency's Al Amal or HOPE orbiter. HOPE is the Arab world's first interplanetary spacecraft, developed and operated by Emirati engineers in collaboration with several universities in the United States. The HOPE orbiter was built in the United States at the University of Colorado, Boulder, with scientific instruments contributed from the University of California, Berkeley, and Arizona State University. With the successful insertion of HOPE into a Mars orbit on February 9th, the UAE became the 5th country or organization to reach Mars, after the United States, the Soviet Union, the European Space Agency, and India. The main scientific goal of the HOPE mission is to provide the first global picture of Mars's atmosphere for every day over a full Martian year. This is done from a wide orbit ranging from 20,000 to 43,000 kilometers, enabling HOPE to view wide areas of Mars. HOPE's continual monitoring in the infrared will reveal the prevalence of local and regional dust storms on a daily and seasonal time frame, which will be important data for planning any human missions relying on solar panels. Another key aspect of HOPE is to better understand the mechanism behind Mars's transformation from a warm world with copious liquid water to the cold, dry landscape we see today. HOPE will contribute to this question by observing atomic hydrogen and oxygen escaping from the upper Martian atmosphere using an ultraviolet spectrometer. Since the arrival of HOPE in February, the orbiter has spent many months preparing to begin the science phase of its mission. One day after it arrived, HOPE captured this stunning image of the Tharsis region of Mars, showing 4 extinct supervolcanoes from an altitude of 24,000 kilometers. A few weeks later, it provided a closer view with this photo of Olympus Mons from an altitude of 13,000 kilometers. HOPE has now completed a gradual transition to its 55-hour operational orbit and commenced its 2-year science mission on May 23rd. The mission team planned to share all their scientific data with the international community, starting in October. If all goes well, the HOPE mission is likely to be extended, with operations running until 2025. The next spacecraft to arrive at Mars was China's Tianwen-1 mission. Tianwen-1 consists of 3 components: an orbiter, a lander, and a rover. The orbiter has several scientific objectives, including the production of medium and high-resolution surface maps, spectroscopically measuring rock compositions, inferring ice distributions using a subsurface radar, and characterizing the Martian magnetic field. Following the arrival of the spacecraft on February 10th, Tianwen-1 underwent aerobraking into its final 265 by 12,000 kilometer orbit. Already, the orbiter has released some fascinating photos, such as this image of Mars's North Pole and this photo with a 7-meter surface resolution. The Tianwen-1 orbiter is now the 8th operational spacecraft in Mars orbit, with an expected lifetime of at least 2 years. But perhaps the most exciting component of this mission is the rover, called Zhurong. On May 14th, after months of orbital surveillance, Tianwen-1's lander was released towards Mars. The lander entered the upper atmosphere at 4.8 kilometers per second, using a heat shield to survive the entry. Next, a parachute deployed and the heat shield was jettisoned, allowing a laser rangefinder and microwave sensor to navigate towards the landing zone. The lander then separated 100 meters above the surface, beginning a powered descent guided by optical and LiDAR imaging for automated hazard avoidance. Finally, the lander propulsively touched down on the surface of Mars. The Zhurong rover deployed from the Tianwen-1 lander on May 22nd and is now beginning its 90-day surface mission. The 240-kilogram Zhurong rover has many science goals, but of particular note is a radar used to search for subsurface water pockets to depths of up to 100 meters. Any residual water in the ancient Utopia Planitia basin could be prime habitats for potential Martian life. Finally, on February 18th, the most ambitious Mars mission to date arrived at the Red Planet. Hurtling directly into the Martian atmosphere from interplanetary space, NASA's Perseverance mission entered the atmosphere at 5.3 kilometers per second, reaching peak temperatures of 1300 degrees Celsius. 4 minutes after entry, the parachutes deployed and the heat shield jettisoned, with the terrain relative navigation system rapidly taking photos to find a safe landing site. 2 kilometers above the surface, the descent stage separated and began its powered descent, captured by this remarkable video from the landing. Finally, Perseverance was lowered from the descent stage by nylon cables in the so-called sky crane maneuver, gently touching down on the Martian surface. The cables then released, with the descent stage flying off to a safe distance. The full 7-minute sequence from atmospheric entry to landing was virtually flawless. The Perseverance rover landed in Jezero crater, near the edge of the Isidis Basin. The roughly 45-kilometer wide Jezero crater is a fascinating destination, since orbital imagery shows that ancient rivers once flowed into and out of Jezero some 3.5 billion years ago, with the crater basin itself once filled by a liquid water lake a few hundred meters deep. Of particular interest is a river delta system, which could have supported Martian life in the planet's warm, hospitable past, and preserved evidence of such life in sedimentary rocks to this day. All of this makes Jezero a fantastic destination for geological and astrobiological research. Perseverance itself landed 2 kilometers from the Jezero Delta and will take around 1 year to travel there. Perseverance is a 1-ton nuclear-powered rover equipped with instruments designed to search for evidence of past life on Mars. On the mast, an infrared laser mode vaporizes rocks into a plasma, with the spectrum of this transient plasma revealing the atomic composition of rocks from up to 7 meters away. A green laser mode provides complementary measurements by probing the molecular composition of target rocks. The mast is also equipped with an infrared spectrometer to identify minerals that were shaped by water in the past. Together, these instruments allow Perseverance to study surface material from a distance and identify promising areas for closer investigation. Perseverance's robotic arm can then examine rocks and soil more closely using a UV laser and X-ray spectrometer to search for organic compounds and also how the chemical composition of rocks may have been modified by ancient Martian life. Besides searching for past life on Mars, Perseverance also features important technology demonstrations for human missions to Mars. 6 weeks after landing, on April 4th, a small helicopter prototype called Ingenuity was detached from the rover. 2 weeks later, on April 19th, Ingenuity became the first aircraft to fly on a planet beyond Earth, briefly ascending to an altitude of 3 meters. Even though Ingenuity only weighs 1.8 kilograms, because the Martian atmosphere is 100 times thinner than Earth, the twin rotors spin at 2,400 revolutions per minute just to achieve flight. Over the course of a month, Ingenuity completed 5 flights, typically flying over 100 meters and staying in the air for over 100 seconds, proving the principle of flight on Mars. Given these successful tests, NASA has decided to assign Ingenuity to a new operational mission phase, where it flies ahead of Perseverance on one-way missions to survey new areas. Recently, the 6th flight test on May 22nd experienced a navigation camera anomaly after flying to 10 meters altitude, causing Ingenuity to tilt and make rapid speed adjustments. But fortunately, Ingenuity still landed safely, albeit 5 meters off target, while a subsequent 7th flight on June 8th proceeded without any issues. The newly proven ability to conduct aerial reconnaissance on Mars could have major implications for human missions. Future successors to Ingenuity could scout difficult-to-access areas like cliff faces, identify promising landing sites for human missions, and potentially even explore lava tubes that could one day support human settlements. A second important technology demonstration on Perseverance is the production of oxygen on Mars from local resources. This is accomplished by the MOXIE instrument, which is the first in-situ resource utilization experiment sent to Mars. MOXIE takes in carbon dioxide from the Martian atmosphere and electrochemically splits it at temperatures of around 800 Celsius into oxygen and carbon monoxide. On April 20th, MOXIE successfully produced oxygen for the first time on Mars. Over the course of an hour, 5.4 grams of oxygen was produced. While this amount of oxygen would only sustain an astronaut for about 10 minutes, this is a crucial demonstration of a key technology required for sustainable human missions to Mars. Perseverance will conduct further experiments with MOXIE over the next 2 years, running it at least 9 times to collect data on how the efficiency of oxygen production in this manner varies at different times of day and for different seasons. Ultimately, future industrial-scale variants of MOXIE could produce copious quantities of oxygen to both refuel rockets and support human outposts on Mars. But the most lasting legacy from Perseverance will come from its sample collection objective. The most promising surface materials surveyed by Perseverance, especially those not representative of Martian meteorites on Earth, will be drilled and extracted by the robotic arm and loaded into Perseverance's sample collection system. Up to 38 sample cores will be collected in specialized sterile sample tubes, with half remaining inside the rover and the other half stored in a cache on the rim of Jezero crater. 5 years from now, in 2026, a daring mission will launch to bring these samples back to Earth. The Mars Sample Return Mission is a joint NASA and ESA initiative. The mission will start with ESA sending a satellite to Mars called the Earth Return Orbiter, which will gradually lower its orbit using solar electric propulsion, ready for the next mission phase. In mid-2028, a sample return lander developed by NASA will enter the Martian atmosphere and land near to Perseverance. A sample fetch rover developed by ESA will spend 6 months visiting the sample caches, or even Perseverance itself, to collect the sample tubes. The samples will then be loaded into the Mars Ascent vehicle developed by NASA, which will launch them in a small container into Martian orbit. orbit. The Earth Return Orbiter will then rendezvous with and collect the sample container. The Earth Return Orbiter then fires its engines to begin the long journey home. In 2031, the Earth Return Orbiter will release a re-entry vehicle containing the Mars samples, which will enter Earth's atmosphere and land in the Utah desert. When the Mars samples are studied in state-of-the-art laboratories on Earth, they will provide a definitive answer on whether any potential biosignatures seen by Perseverance are indeed evidence that life once flourished on the ancient Mars. In the long term, the Mars Sample Return mission will provide valuable lessons for human Mars missions. In particular, the development of the Mars Ascent Vehicle will mature the vital technology of launching off the Martian surface, required to one day bring astronauts back from Mars. Laboratory analysis of Mars samples could also lead to innovative new ideas on how to use Martian materials to build increasingly ambitious structures, accelerating the creation of a self-sufficient society on the Red Planet. Well, that brings us to the end of this Mars mission update. Thank you so much for watching, everyone, and please do let me know if you have any questions or comments down below. The extraordinary progress we're seeing with Starship test flights is just the beginning of humanity's next chapter in space exploration. With new technologies expanding our ability to explore the Red Planet, Mars has never felt closer to Earth. Our long-held dream of exploring the depths of space, of setting foot on distant worlds and gazing upon unfamiliar skies, is finally on the cusp of reality. To make sure you don't miss future Mars mission updates, be sure to hit subscribe and click the notification bell. That way, you'll stay up to date with the latest developments in our journey to the Red Planet.